Hello everyone, this is Ravi Kishore. We'll continue our learning on programming for problem solving using C. And in this session, we'll be looking at a specific important topic called as functions. As a part of functions, we'll be looking at the following topics. First, we'll be seeing some software engineering principles of structured programming and modularity, which are part of a larger problem solving called as top-down development. Then we'll be looking at various types of functions and parts of functions, that is function declaration, function call, and function definition. Then we'll be looking at the topic of interfunction communication. From that we'll be looking at some 4 function basic designs. Then we'll be looking at one type of functions called as standard functions. Then we'll be seeing how to use arrays and pointers in functions. At last we'll be looking at the topic called as function recursion. First, coming to how to design structured programs. So whatever you have seen so far, we should have written most of our code in a main function. Okay, everything we have written so far will be in a single function called as the main, and all these simple programs whatever you have studied so far can be solved and understood without much effort, as the number of lines of code will be very small, and whatever the problems you are going to solve are also simple. But when you go for larger problems, you'll be facing a problem of managing the programs in the sense writing large codes and understanding those codes, and if there are any errors in that particular codes, how to correct them. If you are looking at 10 to 20 lines codes, you can easily identify, understand. If there are any errors, you can easily go to the particular line. When you are going for a 1000 lines code, 2000 line code, that means larger programs, finding the errors and correcting them will be a tougher process for you. So all the large programs have to be divided into some basic elementary parts. This is the main crux of your top-down design. In a top-down design, you basically break down a large program into smaller programs, and those smaller programs can again be divided into still smaller ones, and we try to solve only the elementary parts which are easily understandable. So the principles of top-down design and structured programming dictate that we have a main module and its related modules, and each submodule can be again further divided into submodules. This breaking down of complex program or complex problem into smaller problems, will be calling it as factoring. Okay, so this basic thing of structured programming is implemented by using a topic called as modularization, where you are going to break down your particular program into set of modules. So as you can see, we are going to have a main module. Instead of writing each and every line of code in the main module, you break down that module into 3 different parts: module 1, module 2, and module 3. If this module 1, module 2, module 3 are not elementary, that is you are not able to directly understand that particular module, you break down that module further into module 1A, 1B, 1C in this manner. You can further break down that into some more modules until you find out an elementary part which can be easily understood. You can write the code directly for that one. If there are any errors, we can easily identify in a particular module. Okay, so the modular programming is very easy to manage. Just like take the sense of a real world example of writing a huge book. If you are writing a huge book, you can be having a 3000 pages of a manuscript, which will be very hard for you to maintain first. Even if you are able to maintain the thing, if you are writing a simple mistake, you have to go and search each and every 3000 pages of book. Instead of writing a 3000 pages of book, you can break down that into several volumes which are easily manageable. This is a real world thing where you are going to use the modular programming. Instead of looking at large 3000 pages thing, we will be looking at small pages or small volumes. Next, this top-down design and structured programming, whatever you have seen, that is breaking down a large program or large problem into smaller problems, we are going to implement that particular thing using functions in C language. So the top-down design is basically implemented by using functions in C. A program in C is made up of one or more functions, and one and only one of which should be mained as a main. That is, you are going to have only one main in your C code, and the execution of the program will always start and end at the main. But inside the main you can be calling many other functions, which you are going to see in the further slides. So the main is usually called by the operating system, and the control will return to the operating system once the execution of your main is completed. What is this control, how you are going to return, you are going to see in the further slides. For the time being, know that you are going to have only one main function. Inside the main function you can be writing any number of other functions. So just like whatever you are seeing in the previous slide, where you will be having only one main module, inside that you can be having any other number of modules. Basically you are going to break down the problem solving in this terms of modules. So these functions in C are implemented in this manner. We'll be having one main, and you can be having any number of other functions. If you are solving a large problem, you are going to break down that particular problem into three functions: function 1, function 2, function 3, where your main will be what we'll be calling it as a calling function. The calling function will call the three functions: function 1, function 2, function 3, and these functions, function 1, 2, 3, will be naming it as called functions. That is, the main will be calling these functions, so main will be calling it as calling function. Function 1, 2, 3 will be calling them as called functions. Again, the function 1 can be again calling its own functions to solve the problem, that is function A, B, C. In this particular instance, function 1 will be calling it as called function. Function A, B, C will be calling them as calling functions. In this manner, function 2, function 3 also can be able to call its own functions for the problem solving process. So a structured C program will be present in this manner, where you are going to break down a large problem into smaller problems, and these smaller problems will be implemented by a single function. Okay, where function A will be implementing one small problem, function B will be implementing another elementary small problem. This is the crux of top-down design and structured programming, and we are going to use the functions to implement that particular top-down design here. And first, what is a function in C? A function is a section of the program, or we can call it as a block code that performs a specific task. Each and every function will be a block of code, and it will be performing one task for problem solving. Solving a problem using different functions makes your programming much easier with few defects. Why? Because if you are able to have separate function for each and everything, you can be able to easily identify where your errors are present. But why? Because if your one of the function is not working properly, we can able to localize your errors only in that particular place. Next, a function will receive a 0 or more data pieces and operate on them and return one of the pieces as data. That is, every function will be having whatever you, for example, if you take an addition function, we have to take one or more data values to operate, to perform the addition, and we operate on that one. That operation is addition operation. Once the operation is completed, we will be able to return some result. That result will be the sum result. So the function will be having these things. We'll be looking at functions in more depth. So what are the advantages of having functions in your particular C codes? First, the problems can be factored or broken down into understandable and manageable steps, which are easy to code and debug. Debug means finding errors and correcting them. So we should functions, we should be able to break down your large program into smaller programs, and each program can be easily broken down, and each code can be separated. That is, each and every part of the function, that is, each function can be coded by different people. So the second point, the functions can be developed by different people and they can be combined as one application. So we can have simple functions, each function can be assigned to one people and one person, and they can code it separately. At last, all the codes can be combined into one application. And last, the advantage of function is it supports reusability. Once a code is written for a function, you can use that function in any number of other programs also. That is, once a function is written, it can be called from any other module without having to rewrite the same code again and again. This will save your time on rewriting the code and also errors. Okay, so these are the three advantages of having your functions in the C code. That is, first, you should be able to manage your program easily. Next, while managing means you can assign the work easily when you are dealing with functions, that is in modules. At last, whatever you write can be reused again in the same program or other programs also. So the main advantage, whatever you have seen in the previous slide, that is management part. Each and every code or each and every function can be assigned to a different person. As you can see, James can be working on one module, Susan can be working on other module, George can be working on other module. So James will be writing a code for the inquiry module, and at last all the codes from different persons can be combined, and this part will be calling it as code integration, where we'll be combining codes from different persons, and then indirectly we are developing an application. This is the main advantages of having functions in your codes. Okay, next, in C language we are going to have two types of functions. One will be calling them as library functions or standard functions, or another name is predefined functions, and another one will be calling it as user defined functions. First, in the initial terms, we'll be looking at the user defined functions. In the latter part of the video, we'll be looking at library functions. So the types of functions, the library functions or standard functions are those which are declared or present in the C header files, and some of the functions you have been already using them. That is scanf, printf, getS, putS, square root. And whenever you want to use these standard functions, just you have to include an appropriate header file into your C code. And another types of function is your user defined functions, where whatever the program you want to implement, you can have functions which are created by the C program. Whenever you want to have a code or a function in your program, you can write it on your own. So that is why we'll be calling them as user defined functions. This user defined functions will be, it will help you in code reusability. As I told you in the previous slides, they will be having your advantages of having general functions. First, we'll be looking at the user defined functions, how to write them and how to implement them in our codes. Then later we'll be looking at the library functions. So each and every user defined function or a general function will have three parts: the function definition, function declaration, and the function call. So first we'll be looking at the function definition, next declaration, later we'll be looking at the function call, and later we'll be combining all these three parts to write our own user defined function. The function definition will contain the code for your function, that is what your function has to perform and how it is being performed. We'll be having the part. The function definition will be having two parts mainly: the function header and the function body. So the function header will be having again three parts: the return type, the function name, and the formal parameter list, and will not be having a semicolon there. So the function body will contain some local declaration and function statements in between the braces, as you can see at the bottom of your slide. That is the function definition, where your int is nothing but the return type, and first is nothing but your name of your particular function, and inside the braces, that is round braces, will be having your formal parameter list. Below, inside the curly braces, that is the function body, where we will write our local declarations and function statements. The local declarations, we can have your own declarations, and the function statements are those, the code part which implements your first function. That is, if you are, for example, if you take an addition function, the name of the function can be add, and how many terms you are adding, that will present in your parameter list. and once after performing your particular addition, what should be your result, whether it should be an integer or floating point value, that will be your return type. So every function will be having these three parts, that is the return type, function name, and the parameter list. So remember, this is the function definition. In the function definition, we will not be having the semicolon at the end of your particular thing. Here we will not be having any semicolon at the end of the function definition. Next we will be writing our function code inside that curly braces, where we will be doing whatever the function has to perform. This is the function definition part. Next, the formal parameter list are the variables that are declared inside the header of your function definition. The actual parameters will be present in the function call. Here we will be calling them as only formal parameters. So remember, we will be having the three things in the function: the function definition, function declaration, and the function call. Presently the definition will be writing the code in the definition, what the function has to perform. Next, this is an example of your function definition where you are performing the average. The function definition part is present at the end. It will be usually written after the main. So as you can see, it is the return type is double, that is whatever you are having the result, it will be in double. The name of your function is average. The formal parameter list contains two parameters, one is x and another one is y. Inside your function definition, you are having a sum local variable, so we are calculating x plus y, and later we are performing the average, that is sum by 2, and we are writing a return statement. Return statement will return the result back to the calling function. Calling function means it will go back, the result will go back here. So the result, that is whenever you are writing the return statement, the average value will return back to your main function. So we will be seeing this part again, but you should be concerned about only this function definition, where you are having just the function code, what it has to perform. Remember the return type, the name, and the formal parameter list. Next, coming to the function declaration, whatever you have seen the function definition, before writing the function definition and function calls, you have to declare your function. Just like your variable declarations, you have to declare your functions to tell your program is going to have a function of this particular format. This function declaration also will be having your basic three parts, that is the return type, the function name, and parameters. Here also we'll be calling them as formal parameters, but the function declaration will be having a termination of a semicolon at the end. The declarations are usually placed in the global section above the main. Remember that the function definition will be placed below the main, the function declaration will be placed above the main. Sometimes this function definition, the function declaration is also otherwise called as the function prototype. Next, this is the basic form of your function declaration or prototype, where we'll be having the return type, then the function name, and this parameter list will be calling it as the formal parameter list, and at the end we'll be having the semicolon for this function declaration. This is usually written above the main, remember, and function definition is written below the main. So first we'll be writing the function declaration to tell that our program is going to have one function in this manner. Okay, so in the previous example, if you see, we are going to tell that we are going to have an average function with two parameters, and it is going to return a double result. So that is the function declaration. Next, the third part of your function is your function call. Inside the function call, we'll be having the actual parameters. These actual parameters will be sent to the formal parameters. First we should know the actual parameters identify the values are to be sent to the call function, and they must match the formal parameters in its data type and the order. We'll be seeing about these things in an example. So the multiple actual parameters will be separated by comma. So what will happen in the function call means it will transfer the control from the main function to the function definition. After execution of the function definition, it will return back to the main function. So this is why the main will be calling it as the calling function, the function definition will be calling it as the called function. Okay, the function will be having a return type with void, that is, if you don't have any return type, it can be used as a standalone statement. We will be seeing in the further slides. So the general form of a function call is will be having a return type, the function name. After that we'll be having a set of actual parameters. Remember, in the function definition and the function declaration, we will be calling the parameters as formal parameters. In the function call, we will be calling them as actual parameters. Next, this is an example, a complete example. At the start, this part is the function call, whatever you have written above the function declaration, where you are telling the return type is int and the function name is multiply, and we are going to have two parameters. In the function declaration, we will be calling them as formal parameters, that is multiplier and multiplicand. Just we are going to tell this is a function declaration with a multiply function with two parameters, and we are going to get a result as int. This is the function declaration. Inside the main, we will be writing the function calls. So where you are writing multiply 6, 7, where 6 and 7 are your actual parameters. These actual parameters, what will happen is, whenever a function call is made, the control will transfer from the function call to the function definition. That is, the 6 value will go into x and 7 value will go into y. The control will be transferring from your main to your function definition. Inside the function definition, whatever the statements are present, it has to be executed. Here we are having only the return statement. We are performing x into y, that is, x will be containing the value 6, y will be containing the value 7. So we will be performing 6 into 7, and the result part, that is 42, will be returned back to here. That is, the 42 value will go back to your main place. That is, wherever the function call is present, the control will return back to the particular place, and the 42 will move into the product where you can do anything. So basically the function call is about transferring your control from your main function to the function definition. You can write this function call any number of times based upon your problem statement. Okay, next, this is about the function call. Next, these are other examples of your function calls. You can call with constant values or variables. The first one will be with constant values, where you are passing 6 and 7. The second one, you can pass 6 comma b, whatever may be present in the memory location of b, it will be passed. Next, you can be calling in this manner, where multiply a comma b comma 7. First, the function call will be happening on multiply a comma b, that is, if your a value is 2, b value is 3, first multiply 2 comma 3 will be performed, and you will be getting the result back, that is 6 will be coming. First you can be passing through, if you are getting the result as 6, so next multiply 6 comma 7 will happen. So basically your function call is a postfix expression. First the inner product has to be happening, that is, first the inner multiply a comma b has to happen, then the outer multiply function has to be called. You can call your multiply function in this manner also, where with one variable and one constant, multiply a comma 7, whatever that is present in a, it will be called. And you can be having an expression in this manner, multiply a plus 6, whatever a value can be 3 plus 6 9. So now multiply 9 comma 7 will occur, the function call will be happening in that manner. Or in the last more general sense, multiply expression comma expression, you can be having two expressions in this manner. These are the different function calls, or the different types of function calls you can make in your programs. So these are the three parts in functions, that is the function declaration, function definition, and the function call. So how this function call will work, as I told you in the previous slides. So in the function call, first inside the main, whenever the function call happens, the control will be transferred to the user function definition section, where your function will be executed. Once after the control of your function definition completes, once after the definition, the control will be transferred back to your function call. In this manner your function will work. Generally all the functions will work in this manner. Same is the case with your user defined functions. So this is a simple example of using your user defined functions or writing your user defined functions. In this example you are writing a function which will be multiplying two numbers. So first we'll be having the usual stdio.h header file for using your printf and scanf. Next, first we'll be writing the function declaration parts in the global declaration. So here we are writing one multiply function. The function name is multiply with the two parameters num1 and num2. That is, we are going to tell that we are going to multiply two numbers, not that num1 and num2. We are going to multiply two numbers which are two integers. Remember, the data types also are important here. Once summing the two, we will be getting a result as an int. That is, the return type is an int. That is the function declaration part. And after that we are going to write the main. Inside the main we are having three local declarations, that is multiplier, multiplicand and the product. So we will be using this three. So inside the function main we are taking the input of two values, that is multiplier and multiplicand, and after that we are making the function call. So for suppose if the multiplier is 2, multiplicand is 3, if you give the input as 2 and 3, the function call is going to be on multiply 2 comma 3. So whenever this function call is encountered, the control will be transferred to your function definition. So the function definition is present in the next slide. Here is the function definition. Whenever the function call is made, it will transfer your control from there to here. So here we are going to, so whatever the multiplier and multiplicand values, that is if I consider 2 and 3, the 2 and 3 values will be copied into num1 and num2. That is, num1 will be having 2, num2 will be having 3. So remember the order and type. All the values will be copied from there to here. So this will be telling it as call by value, where you are passing the values here. So inside this is the function definition. Inside the function definition you are multiplying the value num1 into num2, and whenever I encounter the return statements, if you encounter this return statement, it will return back to your main function here. That is, the 2 and 3 value will be multiplied, that is whatever num1 and num2 will be multiplied, and that value will be returned back to here. The result will go to the product. And you are printing the product here. This is a simple program how to use your user defined functions. Remember, we are having the three parts, that is the function declaration, the function call, and at the last we will be having your function definition. The function declaration will be present in before the main. The function calls will be present inside the main. You can have any number of function calls, and the function definition will be having after the main. This is regarding your user defined functions, how to create one user defined function in your program. You can have any number of functions in your program, not only one. You can have any number of functions. You will be writing your function definition only once, but you can have any number of function calls here. That is, you are calling multiply 2 comma 3 here. You can have multiply 7 comma 9 again in the same code itself. You can be calling any number of times, but you will be writing the function definition only once. That's the main thing of your code reusability, where you are reusing the same code again and again for your purposes. This is the basics of your function writing. Next, as I told you, that is about writing user defined functions. All the user defined functions must be both declared and defined. The function declaration gives the whole picture of the function, that is, what is the function name, how many parameters you are going to use, and what will be the return type. Next, the function declaration part will be usually present before your main, that is usually before the function call. The function declaration will contain those three parts. the function definition will contain the code that needs to complete the task. So this is another simple examples where you are greeting. In this particular example, you don't have any return type. As you see the function declaration, you don't have any return type or you don't have any parameters, and inside the main you are making the function call. So when the function call is happening, it will go to here the function definition. Inside the function definition, you are going to write only one thing, that is printf hello world. So whenever, even if you write the return statements or don't write the return statement, after the close brace it will come back to your this particular thing. So this is a simple example where you don't have any return types, and this is also an example for your user defined functions where you are declaring, calling and defining your user defined function. Okay, and from these basic things of writing user defined functions, we can have 4 basic function designs. So the 4 basic function designs are: whenever you have the parameters or without having parameters, if you have the return values or without having return values. These are the 4 function designs. The first one is whenever you have the functions with no arguments or parameters and no return values. When you don't have a return value and no parameters, we will be having one type of function designs. The second type is where you will be having parameters but no return values. The third one is where you don't have parameters but you will be having return values. And the last one is when you have parameters and return values. Based upon presence and absence of your return values, we can be having 2 types. Based upon your presence and absence of your parameters, we can be having 2 types. So we'll be seeing these 4 different types one by one. So these are the basic examples of having the function designs, where you have the first part. This is the part of where you don't have return value and you don't have arguments, where you will be writing the function declaration without any return types and without any parameters. This is when you have the return types, when you don't have the return types but you have the parameters, where you can see we will be writing the parameters inside the function. The second one is where you have the return. Return means in the function definition we will be having return, but you don't have any, you have a return type but you don't have any parameters. The fourth type is where you have the returns, that is int return type, and you will be having integer parameters. So we'll be seeing these 4 designs one by one in the further slides. The first basic design is where you don't have the function return types and you don't have the parameters. So void functions without parameters. So they does not receive any parameters and they do not have any return values. So when you don't have a return value and when you don't have a parameter, we will be writing in this manner: void greeting void. So the return type is void and the parameters are void. So the function definition will be in this manner, where you will be writing without any return type. Remember, whenever you are having return type, you will be returning some integer or some value. Here you don't have any return type, just you are writing return. Okay, so inside the function you are printing the greeting hello world. So once the function is completed, so the function call will be written as a standalone function like greeting message. So if you don't have parameter, just you will be having that open brace and close brace here. Okay, so remember, this is a function without any return values and without any parameters. Next, the function design is a function with parameters but without any return values. If you see, the function receives parameters but does not receive any return value. When you don't have a return value, you will be writing void print1, and since we are having parameters, we will be writing int x in the declaration. That is, you don't have any return value but you are going to use one parameter. First, in this you are writing print 1 of a value is 5, so 5 will be copied into this definition of x, and you are printing 5 here. and the function will return here. So return means you are not returning any value, just you are having a void return, but the parameter is there, which is one parameter. So this is one function design where you don't have any return values, but you have one parameter. Next, the third design is where you don't have any parameters, but you have return values. So when you don't have any parameters, will be inside this parameter list will be having void, and will be having a return as int. That is, we are going to return a result as integer. If you see in the definition, we are going to have a void parameter list, and inside we are going to return the quantity. When you return the quantity, the result will come back here, and it will be placed into amount, and you can do whatever you want to do with the amount. So this is a function design where you don't have any parameter list, but you are having a return type. Next, the last one, where you have both the parameters as well as return types. So this is a basic example you have seen so far. So where you are going to pass parameters, that is square of a, and you are going to return the square here, and the result will be transferred back into your main function. So this is the fourth design where you are going to have both the parameters and return types. These are the four basic function designs where you can use it in any program based upon your perceptions about your problems. Okay, next we'll be seeing the inter-function communication, which will be similar like your four function designs. So based upon how data is transferring or how data is moving from one part of the function to other part, we'll be having three strategies. One is called as downward flow, other one is called as upward flow, the third one will be calling it as the bidirectional flow. The downward flow is from calling function to the called function. The upward flow is from the called function to the calling function. The bidirectional flow will be from both directions. Okay, so we'll be seeing examples for all these three different inter-function communication strategies. First one, as I told you, the downward flow will be from calling function to call function, that is the main to your user defined function. Upward will be from the called function to the calling function. The upward communication will be from the called function to the calling function. The bidirectional will be having from both the sides. So first, the downward flow, where the calling function will be sending data to the called function. This will be one-way communication. So here this will be performed basically by passing data items from the calling function to the called function. So far you have been using this thing in the various function designs. This sending data values from calling function to the called function will be calling it as a call by value, where you are going to pass the values. Okay, rules. So you'll be passing the values to pass the data. So use appropriate data types in the function parameter list to receive those data values. Use parameter identifiers in the call functions to access the local copies. That is, so actual parameters can be different and formal parameter names can be different. Just like you can be having multiplier, multiplicand as actual parameters, x and y as formal parameters. Okay, so in the upward communication will be usually done by using what we can call it as either the return statement, or you can be using something called as by call by reference or passing by reference. So what will happen is, here in the called function sends back your data to the calling function, that is user defined function will send data into your main function. The data items are returned to the calling function from the called function. Calling functions may use the values passed from the call function. In this particular step, values from the called function can be sent to the calling function by using only the return statement. Okay, using the return statement we can be passing data from calling function to the called function to the calling function. Original values of your called function will remain unchanged when you do the call by value. but if you do the call by reference, you can change the original values also. We'll be seeing about the call by reference in the further part of this interfunction communication. So whenever you want to use call by reference, we'll be using the address, and we'll be learning these parts in the next slides. So in the bidirectional communication, we can be sending data from the calling function to the called function, as well as from the calling to the call to the calling function. This will be calling it as bidirectional communication. So we'll be seeing these three things. So this interfunction communication can be implemented by using two types. One will be calling it as call by value. Another one can be done using return or call by reference also. Okay, most programming languages have three strategies. One is pass by value, pass by reference, and passing by return statement. So the downward communication, that is communicating from calling function to the called function. So here we'll be passing the values a and 15 to your x and y. This will be calling it as downward communication. Okay, a will go into your x and 15 will go into your y. Here you are sending your data in a one directional sense from calling function to the called function. Okay, this is will be calling it as the downward communication, and we'll be calling it as call by value or pass by value, this particular downward communication. So this is another example of your downward communication, where you are passing a and 15 into x and y. Remember, if you change the x and y values, the a and 15 values doesn't change. This is a thing about your call by value. So this is one way communication only. We are only passing the copies only, that is 5 and 15. Okay, next, in the upward communication, where mostly the transfer of data will be from the called function to the calling function. So in this thing, we are going to use the call by reference here. So what is this call by reference is, instead of passing values, instead of passing a and b, we are going to pass the address of a and the address of b. So only the pointers can store the addresses. So address of a will go into ax, address of b will go into ay. This sending of address from the calling function to the called function, will be calling it as call by reference. This is passing addresses also. So here you are moving 23 value into the address of a and 8 value into address of b. This will be calling it as indirect reference. We should have learned it in the pointers. So in this the 23 is passed into the a, 8 is passed into b. So this is upward communication, where you are sending data from your called function to the calling function. You can have a similar program where you are passing the address of a and address of b into ax and ay. This is the complete program. So this will be your function declaration. This is the function call and the function definition here. So where you are using the pointers and address to perform the upward communication, or this process we will be calling it as call by reference or passing by address. Okay, the last one is the bidirectional communication. As you have seen, the bidirectional communication is about sending data both sides. Here we are sending data, that is the addresses of a and b from calling function to the called function, and after that we are returning, that is indirectly we are changing using call by reference the addresses, that is the values into a and the values into b. Indirectly, whatever may be the value present in a, we are adding 2 to that one, and we are storing the division value here into b. So here bidirectional communication, we are sending data from calling function to the called function. In this particular example, you are passing the addresses of a and b, and we are sending indirectly we are sending the results back by changing the value of A and B indirectly. This is the bidirectional communication where the data is transmitted between both sides, that is between calling to called and call to calling function. This is the complete example where you are having the function declaration, where you are specifying two pointers inside the function declaration. In the function call, we are going to pass the addresses, the address of A and address of B, and inside the function definition we are indirectly modifying A and B values by using the pointers. So this is the bidirectional communication. So a similar example with indirecting references. So far whatever you have seen, this is user defined functions where you are writing your functions for your own purposes. This is an example of what exchanging two values A and B by using call by references. So other types of functions is your standard functions, where these functions are also having those three parts, that is a function call, function declaration and function definition. But you will not be writing all those function definitions and function declarations. So the standard function definitions are already written and are available in the header files. Okay, declare the standard function that is to be used in the declaration. All these declarations and definitions are grouped together in several header files. One such example is your printf and scanf functions. The printf and scanf function declarations will be already present in your stdio.h header file. Okay, what you are going to use is only the function calls in your programs. All the standard function declarations and definitions will be part of your will be present as a part of your header files, and you are going to just use the function calls in your programs. Okay, so we'll be seeing lots of standard functions here. So how this function without writing, you have to just write your function calls in your program. That is, you will be just using the scanf in your program. You will be not writing the function declaration and function definition of your scanf. The function declaration and definition will be present in your header file. But how does that part will come into your program? When you write #include stdio.h, we are indirectly telling to include the header file into your particular program. But how that will be included will be done by using the particular thing or particular software called as linker. This will be one step in your program execution process, that is linking. Okay, where first you will be writing your program with your scanfs and printfs, and the definitions which are present in your header file will be linked into your program. That is, linked means those two things, that is the function definition of your scanf and printf also will be added to your particular this program during the linking process. Even though you don't write, it will be present in your stdio.h. The linker will add that particular code, the definition code, into your program during the linking process. Only when you link you can execute these functions. So this is about library functions and the linker. So the library functions will contain the function definitions and the function declarations of your standard library functions, and inside the mains you'll be writing only the function calls. The linker will add your particular declarations and definitions into your main program while linking process. This is regarding library functions and the linker. Next, we'll be looking at various standard functions which are present in C language. So first we'll be having one header file called as the math.h to include the mathematical functions, and also we are going to have, so for the mathematical functions we are going to have the math header file, and some standard functions will be having the standard library header file. So we'll be looking at some standard functions in this few slides. First, one such standard function is your absolute values. We can be performing integer absolute function by using abs function, which will be present in standard library.h header file. So this particular function will return the absolute value of a number if you give whatever you give. So we'll be looking at some examples in the further slide. So you can be performing absolute values of real numbers also. Some of the examples are ABS of 3 is 3, ABS of minus 3 is 3. This part is your real absolute value. FABS minus 3.4 is 3.4. So you can perform absolute function for any integer or real values. Just use ABS or LABS to perform long integer absolute value, or for long ints we'll be using LLABS, and for real ones will be using FABS for floating point or double values. Whenever you want to use this particular absolute function in your particular program, just include the standard library.h header file, use it, or use the function call anywhere in your main program. Okay, that is about absolute values. In the similar manner, you can be having ceiling function. The ceiling function can be written as ceil, CEIL, and inside that you can be having double, float, anything. Okay, it will be, a ceiling function is the smallest integer value greater than or equal to a number. So it will be moving it to the upper value, that is 1.9 will be moved to your minus 1.0, 1.1 positive 1.1 will be moved to 2.0. okay, it will be moving your particular number to the right of your number line. Next, you can be using for integers only. So next, in the similar, just like your ceiling function, we can be having floor function, where your particular number will be moved to the left of your number line, that is 1.9 minus 1.9 will be moved to minus 2, plus 1.1 will be moved to 1.0, where it will be flooring the values. Next, the truncate function will truncate your decimal part. In the similar manner, you just have to use these functions in your main, and rounding of function will be rounding it to the highest value, that is minus 1.1 will be moved to 1.0, minus 1.5 will be moved to minus 2.0, 1.9 will be moved to 2, 1.5 will be moved to 2.0. So in this manner we can be using rounding of function also. These are the various rounding of functions you have for your problems. If you want to use any of these, you can use in your problems. Next, you have the power function. So in order to use the power function, you have to include math.h. So you can perform power of x comma y. So it will be performing x power y in this manner. And so if you see power 3.0 comma 4.0, you can use in this manner. So this is regarding the power function. In the similar manner, if you want to find the square root of any non-negative number, you can use the square root of 25.5. It will return the value. All these functions will be present in math.h. Another important standard function you have is generating random numbers. This it will be using further in your future courses. When you want to generate random numbers, we'll be having two types of functions. One is, so this is a simple description about generating a random number. Okay, I think you can understand. If you give a value from 0 to 5, any random number will be generated from 0 to 5. It can be 1, 2, 3 based upon your number of times you call it. If you call once, it will be giving you one random number. So the random numbers, you can be having a series of random numbers in this manner. So we'll be having two types of functions for random numbers. One is seed random and the second one is simple random. In the seed random, we'll be generating different random numbers in different calls, while your general random number will usually give you same type of random numbers. What I mean to say is, if you call a simple random 3 times, it will be giving you 3 random values. Let's suppose 1, 2, 3. If you use seed random, it will be giving you 3 different values 3 different times. It will not always give you 1, 2, 3. It will be giving you 5, 6, 7. It will be giving you 925. the seed random number, with seed random number you will be able to generate different random numbers. By using simple random numbers you will be able to generate random numbers, but successive calls will be giving you same type of random numbers. Okay, so if you write programs in this one, you will be able to better understand the use of random numbers. So when you use simple random, you are going to specify some random max. That is, if you use rand of 100, we will be generating random values from 0 to 100. Okay, you can be using these random values in your functions also. Random values to generate, you'll be using this rand function and srand function to generate random numbers in your particular program. So these are about your standard functions. You can be having any number of functions, you can have any number of calls in your particular program, and any complex mathematical functions can be called by using standard functions. So this is about user defined functions and standard functions. Okay, next further topic is how to use arrays in your functions. So to process arrays in a large program, arrays has to be passed in arrays from one function to another function. That is, you should be able to pass your arrays from calling function to the called function. So passing arrays can be done in two ways, where in the first part you can be passing only the individual elements of the arrays. In the second, you can be passing the complete array. Individual elements means among the 100 values you can pass only one value. Passing the whole array means you can be passing the complete array from calling function to the called function. So the first one is where you are going to pass individual values, and this one we are just passing an integer value a. Just like how you are passing an integer value, you can be passing one individual element of an array. In this you are having an integer array with 10 elements, but in the function call you are passing only the fourth element of your array, that is array of 3. You are passing the fourth element of array, that is array of 3, whatever may be the value, that fourth element will be passed into your function definition. So this is how you can pass only the individual element of an array. So in the similar manner, here you are passing only the value. In the similar manner, you can pass the address also, where you are passing the individual element address. So whenever x modifies, you are indirectly modifying the fourth element in your array. So these two parts are passing individual elements in your arrays. The next one is where you want to pass the complete array. So in this, if you see, you are passing the complete array, where you are passing the array to the function. So you can be passing a variable size array, or you can pass a fixed size array. Fixed size array means you are passing the complete 10 elements. Variable size array means we are passing any number of elements based upon your requirements. So this is the two parts, how to pass your arrays in functions. And the last one we are going to see in this session is function recursion. Basically there are two approaches to write repetitive algorithms. One is iteration, the second one is recursion. The iteration will be implemented by using your for loops. The recursion is another thing where you are going to implement by using functions. So recursion is a repetitive process where a function will be calling itself. So recursion is the process of the function calling itself. So recursive functions are useful in evaluating certain types of mathematical functions. So we'll be seeing some examples. So how we are going to basically design a recursive function. So recursive functions have two types. Each call either solves one type of or part of the problem, and it will reduce the size of the problem. So if you see example more specifically, you understand what is recursion. So each and every recursion will be having one base case where it will be terminating, and will be having a general case will be continuing the iteration process or repetitive process. So the base case will be to terminate your recursion, and your general case will be to repeat your recursion process. Basically, recursion will be used to perform repetition. It will be alternative for your iteration processes. So we'll be seeing this recursion examples one by one. So how to design your recursion function is, first determine your base case, that is where you want to terminate. Then determine your general case, in what way you want to repeat your function, and combine this into a function. Okay, so with an example we'll better understand how to design these recursive functions. So to understand recursion we'll be using the factorial. So the factorial program or factorial to generate or to calculate the factorial of a number, it can be done in two ways, that is repetition. It can be done in two ways, one is iteration, another one is recursion. In the iterative process we'll be using this particular thing by writing a for loop for I is equal to 1 to n. We'll be just multiplying each and every values in iteration process. Coming to the recursive process, we have to first identify the base case, that is base case is where you want to terminate your particular recursion. You will be terminating your recursion when you reach n value is 0, where n value, the factorial of 0 is 1. In the general case we'll be performing n into factorial of n minus 1. So we'll be starting the in order to calculate the factorial of n, we'll be starting at a higher value and we'll be reducing that value until you reach the base case. So the general case will tell you to repeat the process, the base case will tell you to terminate the process, the recursive process. So this process will be performed here. So the function call, that is factorial of 3, will be calling the function. So basically the recursion is a function which is calling itself. So whenever you are calling the factorial of 3, so since it is the base case, that is the 3 value is not equals to 0, it is a general case where it is not equal to 0. Base case means when it is equals to 0. So if you see here, whenever you are calling factorial of 3, it is a general case. So a general case means we'll be doing n into factorial of n minus 1. So n into 3 into factorial of n minus 1 is 2. So here when I encounter factorial of 2, so this is again calling the same function factorial. So we'll be usually writing the function definition only once, but so the first function call will be calling with the factorial of 3. The second function call again will be calling the same function with a value 2. This is basically the recursion where you will be calling the same function. So again when you call with the value 2, so since it is a general case, we will be again performing n into factorial of n minus 1, that is 2 into factorial of 1. Next, the factorial of, again the function will be called with the value 1. So where it is also, since the general case, again it will be performing n into factorial of n minus 1. So where whenever you are calling with the factorial of 0, it will be the base case. When it is the base case, it will return the value as 1. So the factorial of 0 is 1. So when it is 0, it will return to here, that is the 1 value will return to here. So it will be performing 1 into 1. Now the factorial of 1 will become 1. So when the factorial of 1 become 1, it will go back to this place, that is the factorial of, now factorial of 1 will be replaced by the value 1 here. Okay, now factorial of 2 will become 2 into 1, it will be 2. Now this value will go this to this place. Now it will be calculating 3 into 2, and the factorial of 3 will be returned as 6. So this is how a recursion will work for calculating the factorial. And the similar representation can be done here, where 3 into factorial of 2, again it will be performing 2 into factorial of 1, again it will be performing in the same manner. Okay, so this is how the representation, you can have numerous representation in this manner of calculating the factorial okay, in this manner. So if you follow these steps, you will be able to calculate the factorial using this particular recursive procedure. So this is, all these steps are regarding calculating the factorial of 4 and getting the result back to calculate the factorial of 4. At last we'll be wrapping up this session with looking at the differences between iteration and recursion. So iteration will explicitly use repetitive structures like for loop, while loop and do while loops, while recursion will use the base case, or it will use calling its own function. Okay, it will be using the base case and general case to repeat the processes, and it will be calling itself continuously to perform your particular problem. So iteration is terminated by loop condition, fail condition. Okay, so whenever the condition of the loop fails, the iteration will be terminated. Whenever the base case is encountered in recursion, that will be terminated. Next, you may have infinite loops if the condition fails. You may have infinite loops in recursion when there is no base condition in your program or code. Okay, iteration will execute faster and occupies less memory place. Recursive functions are slow and takes a lot of memory compared to your iterative functions. But there will be some advantages in recursion, where some types of problems or some sets of problems you can solve easily by using recursion than iteration. Okay, even though iteration will use less amount of space and it will execute faster, but some problems can be solved by using recursions in a better sense, and it will be easily for you to understand some programs in recursion than in iteration. With this, we'll wrap up our session. Thank you.